solve the system of equations using matrices, we can represent the equations in the form of A, x equals b, where A is the coefficient matrix, x is the variable matrix, and b is the constant matrix. The given equations are we can write this in matrix form. Now, we can use the method of elimination or the inverse of the matrix to solve for x. Here, I'll use the elimination method. Step 1. Form the augmented matrix. Step 2. Row reduction. Eliminate x from the second and third rows. Eliminate y from the third row. Step 3. Back substitution. Now we can back substitute to find z, y, and x. From the third row. From the second row. From the first row. Final solution. The solution to the system of equations is x equals 1, y equals 2, z equals 3. Systems of linear equations, like the one we solved, have numerous practical and real-life applications across various fields. Here are some examples. Physics and engineering. When designing electronic circuits, mechanical systems, or structural frameworks, engineers often need to solve systems of linear equations to ensure that the system is stable, efficient, and meets the required specifications. Economics. Linear equations are used to model economic systems, including supply and demand, inflation, and economic growth. By solving these equations, economists can predict the impact of policy changes, forecast economic trends, and optimize resource allocation. Computer graphics. In computer graphics, systems of linear equations are used to perform transformations, projections, and lighting calculations. This enables the creation of realistic 3D models, animations, and special effects. Some specific real-life examples include air traffic control, solving systems of linear equations to optimize flight routes, reduce delays, and ensure safe distances between aircraft. Financial portfolio optimization, using linear equations to optimize investment portfolios, minimize risk, and maximize returns. Traffic signal control, solving systems of linear equations to optimize traffic light timing, reduce congestion, and improve traffic safety. Medical diagnosis, using linear equations to analyze medical images, diagnose diseases, and develop personalized treatment plans. These are just a few examples of the many practical applications of systems of linear equations. The ability to solve these equations is a fundamental skill in many fields, and it has a significant impact on our daily lives.
Thank you for watching. Like, share and subscribe.